Good morning everyone. Today we will start our new topic regarding the defects. What kind of defects consider over here? Defects in the crystal. Our heading is today defect in the crystal. What is the definition over here? Irregularity in the ideal arrangement represent defect. Suppose I am taking the example of there is a examination hall. There is a 50 students sitting over here according to their roll number, according to their section wise, whatever they are sitting. If any kind of change in their arrangement, suppose one is absent, one is alignment is not proper, so it is represent defect. Are you getting my point? Any kind of irregularity in the structure represent defect. I hope you are getting this point. Okay, so irregularity in the ideal arrangement of crystal, that is, you can write over crystal, that is crystalline solid, represents defect. Okay, and here are the two types of defects of defect. There is the point defect and line defect. What is the point defect? Irregularity in the ideal arrangement of atom at a point. What is here? Look at over here. Suppose the structure is like this. Each and every point attached whatever the atoms are there, atoms, molecular ions. If one atom is missing over here, it is also point defect. If another atom is coming from here, it is also point defect. If he is not here and another one is over here, it is also point defect. Any kind of irregularity in the ideal arrangement at a particular point, any kind of irregularity in ideal arrangement of at a particular point represent the point. Are you getting my point? Point. I hope this is clear. Okay. Point defect, irregularity of ideal arrangement of atom at a particular point represent point defect. Okay. Next, irregularity. What is here? Further, I will explain it as three types: stoichiometry, non-stoichiometry, and impurity defect. I am explaining. This is a very important topic for today's. Next is line defect. Just listen this. Irregularity in the ideal arrangement of alignment. Suppose I am taking this example. This is the line in this way. Particles are just next to each other. The particles are just next to each other. Suppose any kind of change. Suppose this line is not straight. It is go like this. It is go like this. Alignment is not exactly which is standardization. Just one atom is just next to one atom, but the alignment should be horizontal, but it should be disturbed due to some reason. So the alignment is not proper. So this represent the line defect. Are you getting my point? Irregularity in the ideal alignment is represent line. किसी भी तरह की लाइन में error represent the line defect. Are you getting my point? Just pause the video and note down these points. Okay, I hope you note this. Just I'm rubbing this. Okay, now point defect has a three types. Now point defect has a three types. I'm explaining and further and its type also. First, point defect. Point defect has three types. Basically three types. Three types. One is stoichiometry defect. Stoichiometry defect. Second is non-stoichiometry defect. Stoichiometry defect. Non-stoichiometric defect. And third one is impurity defect. What is stoichiometry? Suppose first of all understand what is stoichiometry. Stoichiometry defect. After that you will understand what is stoichiometry defect, non-stoichiometry defect, and impurity defect. So let me first of all explain. After that I am writing the points regarding this. What is stoichiometry? In your textbook there is only one line written over here. Do not affect the stoichiometry. What is stoichiometry? Suppose I am taking the example of NaC. 100 molecules of Na, 100 molecules of Cl. It is in the ratio of 1:1. Suppose 200 is available, 200 and 200, 1:1 ratio available in this. So what is stoichiometry? What is the ratio given in the formula? It is available in the reality. Ideally, it is the ratio is 1:1. So in the reality is also available 1:1. Suppose I am taking the example of one class here. 100 boys and 100 girls are available. Okay, what is the ratio of girl and boys? 1:1. Suppose one boy is absent. On that time, if there is a ratio of boys and girls is 99 is a 99. So what is the ratio? 1:1. So it does not affect the stoichiometry. What is stoichiometry over here? Which ratio available in the formula? It is available in the reality. Always available in the reality. So in this type of stoichiometry defect, what is the ratio is given in the formula? Always available in the reality. It does not affect the stoichiometry. It is represent a stoichiometry defect. Okay? It does not affect. What is stoichiometry? I am getting my name. What is the ratio? Whatever the ratio available in the formula, it is available in the reality. So it is represent stoichiometry defect. Okay? Just now note down this point. Next, what is non-stoichiometry defect? What is whatever the given ratio? Suppose boys and girls. Again, I am taking the example of 100 boys and 100 girls are in the class. Suppose due to any reason, boys are all are present, but girls is one is absent. So what is the ratio? Ideally, a ratio should be 1:1, but reality is not in the 1:1. It is the 1:0.99%, 0.99 ratio available. So it is what is non-stoichiometry? It affects the stoichiometry. Which ratio should be available in the formula? It should not be present in the reality. Okay? Are you getting my point? I hope you are getting. Just note down this point very clearly. Okay? In this, the ratio should be always different. The ratio should be always different. It is represent non-stoichiometry defect. It is represents non-stoichiometry defect. Next, further I will explain what is impurity defect. It is last point I will explain you. Just write down this point. What is stoichiometry? Stoichiometry is what? What is the ratio available in the formula? It is not available. It is available in the reality. But in non-stoichiometry, the ratio should not be available. Whatever the standard ratio in the formula, it is ideally not available in the reality. Okay? Just I am writing the definition over here. Just rubbing this. Just point note down this point. Okay? And what is non-stoichiometry defect? Just write down these points. The defect which do not affect the stoichiometry. Which do not affect the stoichiometry. I have already explained what is stoichiometry. Whatever the ratio is available, it should be available in the reality. This do not affect the stoichiometry of crystal lattice. Crystal lattice represent stoichiometry. Just write down this definition very clearly. Okay, I hope you are done. Next, it has a two types. Stoichiometry defect has a two types. One is vacancy defect. Vacancy defect, and second one is interstitial. Okay, it has a two type: vacancy defect, interstitial defect. I am explaining the first point. I am rubbing this first definition. Stoichiometry. I have to write down this. What is vacancy defect? What is vacancy defect? In this, there is a diagram also. Suppose I am first of all explaining the diagram. Atoms are arranging like this. Atoms are arranging molecules. Atoms are arranging like this. And one particle is absent. one particle is absent, equal number of this, suppose one particle, yeah, one or two more particle. The particle is vacant, is not available. Particles are not available in the reality. It is represent the vacancy defect. Write down this definition. The space are vacant, clearly vacant over here. Okay. In this defect, the constitute particle is not available at its point, at its lattice site, the vacancy is available at that place. The vacancy is available at that place. Represent that place. But the definition is enough. In this defect, the constituent particle is not available at its lattice site. In this defect, the particle is not available. If suppose 100 boys and 100 girls, so one girl and one boy are equally absent. Okay, no one is replaced over here. The vacancy is available at that place. It represent vacancy defect. Okay, vacancy defect. Just make the diagram from your textbook. It is also available in your textbook. You can write the space is vacant. Okay, write down this point. Okay, I hope you are getting my point. Vacancy defect. I am rubbing this. Next it has an interstitial defect. Okay, what is interstitial defect? Interstitial defect. Second one is interstitial defect. What is interstitial defect? What is, first of all, understand what is interstitial site. Suppose I am making a diagram like this over here. There is a space between the particle. There is a space. It is a space in the particle. Okay. The voids, the vacant space also. If any particle come over here, okay, the idle arrangement from somewhere else, I don't know. Taking any other particle from the interstitial space, interstitial site. If any other particle from the same molecule, same atom is available at the interstitial site, represent the interstitial defect. In this type of defect, the constituent particle is available at interstitial site. The constituent particles is available at interstitial site, represent interstitial. Okay, here look at over, if any other molecule, atom or ion come from at an interstitial site, the density will be increases. The next point is density will be increases. This is arrow represent. Just write down this definition. If the constituent particles are available at an interstitial site, represent interstitial. ID means interstitial defect. The density will be increases in this type of defect, interstitial defect. I hope you are getting my point. Okay, students, interstitial defect has a two type. One type is a Schottky defect. What is Schottky defect? Suppose it is represented in ionic solid. Cation, anion is like this. Anion, suppose one is missing is over here. Anion, cation, anion, cation. Suppose one another is over here. And one is cation and anion. Okay. It is first of all one thing in Schottky defect. Interstitial have two types. One is a Schottky defect, one is a Frankel defect. Further, I am explaining this point. What is happening in Schottky defect? Equal numbers of cations and anions are missing. It is represented in ionic solid. What happened in ionic solid? Cation, anion, are alternatively arranged. Are you getting my point? Cation, anions are alternatively arranged. So whatever, suppose one cation is missing, one anion is missing. Suppose there is in section 100 boys and 100 girls are there. Suppose 2 boys are absent, so equal number of girls are also absent. 98 is 98. Equal number of cations and anions are missing in this type of defect. Okay. So what is first point? Available in the ionic solid, because ion should be there. Cation, anion should be there. One. Equal number of cation and anion are missing. Equal number of cations and anions are missing. Second point. Okay. If the 2 girls and 2 boys will be not available in the structure, density will be, because volume. What is density? Density is mass per unit volume. Suppose volume is fixed. Suppose volume is whatever is fixed. Mass is decreasing because number of students are absent. So density will automatically decrease. So density will decrease. Example: NaCl, KCl, CaCl. Are you getting my point? Just pause this video and write down this point. Schottky defect available in solid. Equal number of cations and anions are missing. Density will decrease. Example: KCl, NaCl, CaCl. Okay. Next, another one is Frankel defect. I am rubbing this point. Okay. What is interstitial defect? Is a 2 type. Next is Frankel defect. Frankel defect. It is also available in ionic solid. Available in ionic solid. Available in ionic solid. Ionic solid. Equal number of cations and anions. In this, what happened? Suppose all the suppose whatever cation and anion are available. Cation and cation. Okay. Equal number of cation and anion available is this. Suppose what happened? Cation has a smaller size. In general way, cation has a smaller size. Due to small size, it can move. It can slip from over here to here, here to here, any kind of place. So what happened in this type of defect? In this type of defect, constitute particle. In this type of defect, cation is not available at its point and present in the interstitial site. In the interstitial site of the solid. Second point, what happened? Suppose the cation should be here, but he is not available over here. The vacancy is over here. It is available over here. Why? Because cation has a smaller size. It can be shifted anywhere as compared to anion. What is the reason? What is the reason cation has a smaller size? In the 11th class, there is a Fezan rule. It is explained cation has a smaller size because it donates the electron. Effective nuclear charge increases, so size will be decreased. Okay. Density. What happened with the density? Density remains same because it is available in the structure. Suppose 100 boys and 100 girls, one boy is available in the class but not in its position. So density never affected. Why? Because mass is fixed. Okay. So this is called Frankel defect. Available in ionic solid. In this type of defect, cation is not available in its site and present in the interstitial site due to small size. Next point I will do, due to small size. Okay, students. Are you getting my point? What I am trying to say to you? Okay. Density will remain same because it is available in the structure. Density will remain same because it is available in the structure. Okay. So these are the what happened today. We will study the defects. One is point defect and line defect. Point defect is a particular point is missing over here. Point defect basically has a three types: stoichiometry, non-stoichiometry, and impurity defect. Stoichiometry, what happened? Whatever the ratio is available in the formula, it is available in the reality. Does not affect the stoichiometry. What is the ratio is available? It is available always in the reality. Represent the stoichiometry defect. It has a two type: vacancy. The vacant space is there. Next is the interstitial defect. Interstitial defect is interstitial position. Atoms are available. Next, Schottky defect. There is shortage of atom. And Frenkel defect is the cation is small size due to can shift anywhere. Thank you, students. We will continue the topic later. Thank you. All the best.